Hey there, awesome physics students. I wanted to talk again about this example, but this time I want to talk about how does voltage behave in these kinds of circuits. We know that current splits because current behaves like flow, but recall that voltage differences are closely connected with the potential energy. So what we're thinking about here is the potential energy difference between 2 points. All right, that's why we're using this symbol delta here. Okay, so we have this circuit here. All of the resistors are identical. That's not really important right now, but we have a battery or some voltage source that provides 9 voltage difference between the top and the bottom. And I'm going to treat this part as it's connected to ground, which means it's at 0 volts here. That means that this is positive 9 volts, or the difference in voltage from here to here is positive 9 volts. Okay, so the principle here is that there is a voltage difference or a voltage drop anytime you have some resistance. These wires here we're treating as if they have 0 resistance. So if I look at the voltage here, that's going to be 9 volts compared to 0 here. And if I check the voltage again here, well, it hasn't lost any energy in going from here to here. And so this is still going to be 9 volts. And again, all of these are relative to the 0. So I'm thinking about the voltage difference from here to here. If I look from here to here, if I go from there to there, that also does not take any energy. So again, I'm still at 9 volts. If I go here, I'm still at 9 volts. Now if I go from here to here, imagine a charge going from here to here to here to here. If I want to take a charge from the top of the resistor to the bottom of the resistor, now this will apply. I'm going to lose energy. That charge will lose energy as it goes through that resistance. So as it goes through, if it goes halfway, it's going to lose half of its potential energy, or 4.5 volts. But I'm going to go all the way through, and so I'm going to lose all of the energy. So now this is going to be at 0 volts at this point right here. And again, the voltage difference from here to here is 0 volts. Now how did I know it's 0 volts and not like 7 volts or 5 volts? How did I know it lost all of its potential energy? Well, let's again do what we did up here. We'll just do it down here. If I go from here, this point is 0 volts. That's what we've defined it to be. If I go from here to here, that's going to be, of course, this is all one wire. This doesn't take any energy to move a charge from here to here because the resistance is 0. So this is still 0 volts. And this junction here is going to be 0 volts. And this point, going from here to here, it's still on the same wire. And so this point is going to be 0 volts. That means going from here to here is going to not cause any voltage difference either. And so this point, and this point, and this point, and this point, and this point all have the same voltage. And so that means this must be 0 volts. Okay? Or it lost all of its 9 volts in going from here to here. Now what happens over here? Well, let's say that as it let's again start over here. It's 9 volts here, it's 9 volts here. As it crosses this junction, well, at the junction, it's still 9 volts. Still connected to this same wire, so it's still going to be 9 volts there. If I move the charge along this wire, again, this wire has 0 resistance. It doesn't take any energy to move this charge down here. So it's going to have a potential of 9 volts there. Again, this junction is going to be 9 volts, and this point right here is going to be 9 volts, as is this point here. This is going to be 9 volts as well. I can move this charge from here to here to here to here. It's all along the same wire. It's in the conductor. It doesn't take any energy to move that charge to those different points. But if I want to move it from this side of the resistor to this side of the resistor, now there will be some energy loss. And let's say that as it goes from here to here, that I find out that the voltage difference here is 3 volts. So it loses 3 volts in going from here to here. So that what we call that the voltage drop across this resistor is 3 volts. Well, if the voltage drop is 3 volts, that means that it started at 9, it gets reduced from 9 down. It loses 3, so now it's at 6 volts here. So this is 6 volts. This point here is 6 volts. Now, if I've done the same thing what I've done here, that means this junction is 6 volts. That means this is 6 volts. That means this point is 6 volts. In other words, the voltage difference from here to here across this resistor is going to be the same as the voltage difference from here to here. And of course it would be, because it's the same 3 ohm resistor, right? This is just reflecting that I can, when charges go through here, they can take two different paths. They can lose energy. They don't lose any energy on this traveling from here to here, but they can go either through this resistor and they lose 3 volts of energy per charge, or they can go this path and lose 3 volts of energy per charge. But in either case, going from here to here, they have lost 3 volts of energy per charge. And so the difference there is going to be 3 volts. So now the potential, again, this potential is 6 volts compared to this 0 point down here. And going from here to here, you guessed it, this point is 0 volts, this point is 0 volts, this point is 0 volts, this point is going to be 0 volts. That means it goes from 6 to 0. That means the potential difference here is going to be 6 volts, or the voltage drop across this resistor is 6 volts. That's the energy a charge loses in going across that 6 volt, that 3 ohm resistor. Notice, important to notice, that when I go from here to here, I've lost 3 volts, and when I go from here to here, I've lost 6 more. So the total is always going to be the total same as going from here to here, right? I go from 9 to 0, or I go from 9 to 0. If I take this path, I lose the same amount of energy as if I take this path, or if I take this path. No matter, the potential energy only matters where do I start and where do I finish. It doesn't matter the path that you take, okay? Hopefully this illustrates some of the important differences about how current behaves versus voltage behaves. You should always refer back to this model. Make sure that you understand this before you start working problems, because if you don't understand this, the problems are going to be too difficult. All right?